Hello, in this video we will look at the imaginary unit I. The imaginary unit I is defined as I is equal to square root of -1, where I squared is equal to -1. So let's do a couple of examples where we rewrite numbers as a multiple of I. In this example, we have a square root of -9. Before imaginary unit I, this would be the last step and we would not be able to do anything further with the number. However, now we can rewrite this as inside of the square root, -9 can be rewritten as 9 times -1. So we can break this radical as square root of 9 times square root of -1. We can rewrite 9 as 3 to the second, so we will have square root of 3 to the second times square root of -1 is equal to I. So let's put I instead of -1, and now we have square root of 3 to the second times I. Square root and a second power will cancel, so we are left with 3I, and this is our solution. In this example, we have to rewrite square root of -11 as a multiple of I, and let's begin by rewriting this as a square root of 11 times -1. On this step, we can break the radical as square root of 11 times square root of -1. Square root of -1 is equal to I, so instead of -1 we will write down I. 11 is a prime number, so we cannot rewrite it in terms of second powers. This means we will leave this as is, so we will have square root of 11 times I, so square root of 11I is our solution. In this example, we have square root of -48. Let's begin by factoring out negative from 48, and we will have square root of 48 times -1. On this step, we can break the radical and have square root of 48 times square root of -1. Let's see if we can simplify square root of 48. Let's begin by factoring 48. 48 is 2 times 24, 2 is a prime. 24 is 2 times 12. 12 is 6 times 2, 2 is a prime. And 6 is 2 times 3. And now everything is in terms of primes. So 48 can be rewritten as 2 to the power of 4, because we have 4 factors of 2, times 3, which is left over. 2 is raised to the power divisible by 2, so 2 is a perfect square. This means we can break down square root of 48 into square root of perfect square. So we have square root of 2 to the 4th times square root of a leftover, and we had a factor of 3 times square root of -1. We have square root of 2 to the 4th. Let's take the second root by dividing this 4th power by 2. So we will get 2 to the 4 divided by 2 is 2. So 2 to the second. Square root of 3. Square root of -1 is equal to I. So we have 2 to the second square root of 3I. This is equal to 2 to the second is 4 square root of 3I. And this is our solution. That's all.